Hello, this is an introduction to Galaxy. Today we will talk about what is Galaxy and we'll have a walkthrough through the interface. What Galaxy is not. Galaxy is not Excel. It does not allow you to look at the data in the way that you see in this Excel table and edit it. It is also not a programming language. It does not replace Unix or Linux, nor does it replace them. On the right, you see Microsoft attempts to develop a tool that allows you to manipulate DNA data. As you can see, it's very threatening and unuser friendly. And this is not what Galaxy is about. Galaxy is actually a shell. It's an interface. It allows you to connect to data repositories such as UCSC tables and download data to your Galaxy environment. It allows you to connect with third-party tools such as Bowtie and Anovar and access them because there is an interface already built in Galaxy. You can build interface to other tools. It has some built-in tools that allows you to do statistics and graphics, and you can access Linux commands without actually typing them, without using the command prompt. Um, it's free, it's open, it is a web-based platform for biomedical research. All the data is being downloaded to your Galaxy environment, never to your computer, but you can download it to your computer. The interface is very simple, and most importantly, you can generate pipelines. So a command that calls another command that calls another command, and you can reproduce those, you can share those, and you can print those and include them in your publication or your lab report. It is developed by Johns Hopkins and Penn State and a very large community of users. Galaxy makes our life easier because it teaches us about the command without actually having to type them. It has very simple way and fast ways to access and process text file. It will teach you how to build pipelines, which is something you'll need to know because it is needed by large projects such as 100,000 genomes. It allows you to handle large databases very quickly. It can be customized. You can add tools to Galaxy. There is a very large number of videos and documentations, and it's pretty much simple to learn. These are some resources about Galaxy. We will access Galaxy 3 through this link right here. This is the main window of Galaxy. There are four main components. There is the menu bar on the top. This is your history. It's a log of everything you do. All the commands that you type make Galaxy do are here. This is the main window. It would show you several things, but right now it shows you the outcome of the commands in here. This is not the prompt window. You cannot type things here. This part is the most important part. It has all the tools and commands, and if you click on each one, there will be a window opened with many more commands that you can type. Let's look at the menu bar. So the first one you already saw, this is the main working environment. The second one allows you to create, edit, share workflows. So you can see this workflow starts with an input file. It's a bed file, and then it's being processed through two filters. Okay, then the outcome is becoming the input of a third-party tool, and from here we're choosing this option to go into a final file. Okay, so if you want to run this pipeline again for a new bed file, all you have to do is just click on start and it would run for you. Here you can access other published data and workflows of other users. You can visualize your genomic data. Here you access help. And finally here you can log in and out of Galaxy. You can work in Galaxy without logging in, but it's strongly recommended that you will because, again, it allows you to record and save your history. This is your history. It is recommended that you give it an informative name because the idea is that you can go back to your history at any time and run on the commands again without actually typing them again. Galaxy gives names to everything that you do. Here, it filtered data produced in number 74. This is number 74. It's a map with BWA. Okay, so it's a command that follows command that follows command. Every step is another processing of the data, and you can change those names if you don't find them informative, just to allow you to remember what you did. This is the tools menu. Here you can get data from UCSC tables or Fly database or Yeast. This is the text manipulation menu. You can convert the data to tabs. You can extract columns, cut columns, merge two tables together, and do all sort of things that you should have otherwise done with Linux command. Here, Galaxy allow you to do it very quickly. Um, Not all galaxies are the same, since anybody can install Galaxy on their own server and install their own tools. Different Galaxy instances would have different tool sets, but they would all have the same tools that we just saw, the same one that exists on the main version of Galaxy. Okay, so why won't you give it a try? Try to count the number of human SNPs with missense and loss and stop loss on chromosome 21. um, this is, and try to put together some kind of workflow. This is a very quick solution. Try also to do all the things in here. The next slide would show the solution. So don't turn to the next slide before you give it a try. This is the solution. Two solutions, in fact, and they're not really good. So you can do it a lot faster and much better. So give it a try. Thank you so much.